Hello, it's Ross Wilson with the Ausable Bayfield Conservation Authority. Today I want to share with you some of our work towards scaling soil health from fields to watersheds. The Ausable Bayfield Conservation Authority is a 600,000 acre watershed on the southeast shore of Lake Huron. It's home to a diverse agriculture, mixed agriculture, both livestock and grain, and more to the point, it receives 39 inches of rain annually every year, some of that in the shoulder seasons. So water issues are obviously some of a big issue. Soil health, water quality are very important points. We came across this site in 2013. It was something we came across by accident. We have side-by-sides. On the left-hand side, water quality impairments, the rills in bad shape, little residue on the surface. In contrast, on the right-hand side, there's a beautiful spot there. Nice corn is all in good shape. Keep in mind the same soil, same slope, and the same rainfall, but clearly there was different management here, and it caused problems, obviously, from one to the other. The other thing to keep in mind is whatever comes off, any sediment, nutrients that come off those slopes, they're in Lake Huron within 3 miles. So as soon as it hits the outlet, it's gone and it's into the lake in no time. So we need to be very aware of some of our soil health and how that's affected by our land management. So we were able to try to set up a project here to see if we could kind of link the water quality good on dad to soil health properties. We looked at 5 different landscape positions and we looked at 5 different soil health metrics. What we're able to find there was, yes, by using these 5 metrics, each one of them consistently showed that the soil health was much worse on the poor site where the water quality and rills are, and much better. The difference of 2.1 versus 3.3, so forth. In particular, aggregate stability, fairly low at 60%, 62% for the water quality. So any aggregates that do get broke up will get washed right into the lake. In particular, the very bottom is yield. Could be a good or bad indication of soil health, but in this particular case, this is what we're looking at. So any water quality, those rills, 65 bushel, and the good site was 201. So fantastic difference. So this is an example. You can see our watershed there in red. What we're trying to do was hopefully scale up some of our soil health metrics from a field scale up to our watershed scale, but also have them relevant on a fairly larger scale as well across Southern Ontario. When we're talking about scaling, we're really talking about scaling up or versus scaling down. And what I mean by that is if you're scaling from a field scale up to a larger scale, it might be a county scale, it might be a watershed scale, it might be even larger. That's scaling up versus from a region or from a larger scale down to the field scale. I'm going to call that scaling down. And when you're scaling from the field to the region, you're scaling up. Some of the things to consider are how many samples you actually need to go out and sample. Clearly, the variability of your soils will have a big factor on that. The variability within your management as well. So for example, if you have soils that are very uniform and these soils support, let's say, a grain industry and it's dominantly no-till, well, then your scaling will be much more effective under that scenario than it will be under our scenario, where we have highly variable soils, we have highly variable management regimes with both livestock and grain, and we have a wide variety of tillage practices. The other side of the coin is if we're going from the region down to a field scale, then it involves the use of hyper or multispectral data. And one of the challenges that we noted from a survey that we did in 2018 was the pedotransfer relationships between the hyperspectral data and the actual field data, in some cases, was rather poor. So it's something that will get better in the future. Some of the compromises that we're considering, accuracy versus spatial coverage. And you tended to either get one or the other. So if you wanted accuracy, chances are then your spatial coverage suffered. If you want spatial coverage, then your accuracy was going to suffer. Obviously, accuracy better on a field scale, spatial coverage better on a larger watershed, county scale, whatever. So really, depending on whether you want to scale up or scale down, it really depends on the objectives of your particular study and which one is more important. Not all metrics also are likely to scale equally well. Some may be better than others. At a field scale, we have quite a variety of different soil health metrics, but not all of them are going to be able to scale up equally well. So for example, something like organic matter, you might be able to scale up better than something like resistance to penetration, where you can get differences of compaction on headlands, on buggy trails, you name it. There's also a fairly minimal metric set that it's available at a broader scale. We've worked with a number of different organizations, and one of the things that we've tended to find out was that over winter cover, so this is just simple residue on the surface over winter time, which is one of our more vulnerable times because of surface runoff. Even over winter cover, very simple, but we're able to get some good data out of that. In our attempts to try to scale up, we decided we were going to go and scale up from the soil, the field scale up. It was something that was more suitable to our objectives. We're looking at field sampling from some of these fields on the left and up to our watershed. That's our watershed with our 6 different watersheds, sub-watersheds identified. And the challenge becomes, well, what is your field sample? Where are you going to sample it? And what is it going to be representative of? So for example, this purple area, top left corner, is an old lake bed. So because it's fairly uniform and the practices are fairly uniform in there, then you would need minimal samples and it might be representative of a large area. The sharp contrast to that is anywhere else on that page where there's tremendous amount of variability. And once you did decide to field sample, what is it representative of in those areas? Some of those farmers have 3 different soil types on them. So it's one of the challenges that you have to deal with when you're trying to scale. The other thing that we ran across was just differences in our soil surveys. One from 57 was pre-GIS, so it's a little coarser in terms of data definition. In 1992, our Middlesex soil and map, all our soil surveys are done on a county level. So the Middlesex County at that time would have had some GIS involved in determining the soil maps. So you can see the difference, and that has influences if we're going from a field scale up to similar soils at a larger scale. This is a soil survey of our entire watershed. There are 30-some different soil types within there. It's a glaciated landscape and just a huge amount of variation. We can't handle that kind of variation. Just the sampling alone would be crazy. So we reduced this particular 30-some soil types down to 4 different soil textures. They're bounded by coarse sand on the one and fine clay on the other. And then 2 intermediaries were just loams, kind of a heavy loam and a light loam. And we divided our whole watershed into these 4 different soil textures so we could start to get a handle on it. One of the things that we were considering was we weren't talking about static soil properties that don't change over time. They change over time, but not space. So these, for example, is texture. So the soil health, in contrast to that, is really the metrics that we were looking at. These are things that change with management. They change over time and over space. And infiltration rates and organic matter are great examples of the soil metrics that we were trying to scale up. We looked at 19 different farms, and we were able to take these soil metrics that are located on the left-hand side: organic matter, bulk density, resistance to penetration, and infiltration rate. And we took 19 farms on those 4 textures. And that's 19 in total. That's not 19 farms on each of the 4 textures. So the farm soils, we took those soil health metrics on the farm soil, and then in comparison, we wanted to look at what the native condition was, so we get some sort of sense of how degraded that particular soil was. So for example, we simply took the farmed value, we compared it to the benchmark value, and we laid out a couple of scenarios here. So for organic matter, if the farm value was 6, benchmark was 6, we're looking at a ratio of 1, which was very good. In contrast, if the farm soil was a value of 2, benchmark was 6, we're looking at 0.33, which was fairly poor. And what we ended up doing this was for all of these soil health metrics down the left-hand side. And if we had had enough soil samples from different, we would have more comfort level in scaling up. 19 farms across those 4 textures was only 5 farms per texture. And if we were able to get a much larger number, we'd be able to assess what that variability was to a greater extent, and then we could have a better idea of how valid our scaling efforts were. What we did find out though was some health metrics were better than others. Bulk density at a ratio of 0.72, which ended up being the worst. What that says is really that bulk density wouldn't be the greatest soil health metric to determine soil health in one thing, but also to scale up from that. In contrast, infiltration rate did a fairly reasonable job at 0.21. It was one of our better metrics that we did for this exercise. It could discern differences between different practices, different management practices. So as a result, we could do a much better job of using that as a scaling factor. Were some soils less healthier or more healthier than others? In fact, there were several metrics here. The heavy loam tended to be the very worst. We have something called 100-hour soils that fit into that category. They go from too wet to too dry, and it's very difficult to get your work tillage and your planting done in that 100 hours. In contrast, we're looking at some of our loam soils are very beautiful, beautiful soils. It seems like you can't do anything wrong with them. So this is just some of the details, some of our efforts. Again, if we had more samples, we would have been able to get a better idea of how good some of these metrics could be used for scaling up. But at this point in time, we haven't quite crossed that bridge yet. But looking forward to any further comments regarding it as this symposium goes on. What we summarized really was you have to know what the purpose of your study was. Are you interested in accuracy, or are you interested in spatial coverage? We know that all net metrics are not going to scale up equally well, so that's important, again, to know back to your purpose of your study. And if accuracy is really the key thing that you want to look at, then you're probably looking at scaling up from a field scale. If spatial coverage is more important to you, then maybe it's more important to get a large-scale spatial coverage of your data and then try scaling down to the field scale. So with that, I'm going to wrap up and look forward to interacting with everybody at the symposium.